Hello, my name is Alexander Papuga and I'm doing presentation for 4.2. In this presentation, I will be looking at anthropometric testing, somatotyping, assessing the suitability of these tests, evaluating different protocols, and using results to interpret sport performance. First, there is the Durnin and Wormsley 4-site measurement test. Those sites are bicep, suprailiac, tricep, and subscapular. You should measure 3 or 4 times on each side to get accuracy. After that, you add 4 results together and put them in the equation shown. They are different for males and females as well as the different ages. Those results will show you the body density. Jackson and Pollock is a 7-site measurement test. Those sites are chest, mid-axillary, tricep, thigh, abdomen, suprailiac, and subscapular. Again, they do not change whether your client is a male or a female. And once again, you add the sum of the skin folds and put it in the equation. The equation, however, doesn't matter for male and female. The answer will tell you the body density. Series equation is used to find out body percentage using body density. So you put the body density from the previous test and you can check what is the body fat percentage. Sloan equation shows skin fold measurements is using skin fold measurements to get body density. It is different for males and females. For males, they only need thigh and subscapular. For females, they need suprailiac and tricep. You can use those body density to put in the series equation to find the body fat. Normograms is calculating body fat. For females, you have to measure tricep, thigh, and suprailiac. For male, you have to measure chest, thigh, and abdomen. You add up those 3 skin folds and draw a line from your age to the sum. It will go through body fat percentage, and that's what the answer is. Body mass index, as well known as BMI, is weight divided by height squared. Ponderal index, or PI, is weight divided by height cubed. Waist to hip ratio is smallest waist ratio plus largest hip measurement divided by 2. Bioelectrical impedance analysis, or BIA, is input. You input height, weight, age, and gender into a machine, hold for a few seconds, and the machine will tell you the result. Those will include body density and body fat. Lean body mass. For males, there is a different calculation, and for females, there is a different calculation. You need weight and height to complete that. There's also, for somatotype, there is the Heath-Carter rating system. There is 3 different body types. There is the endomorph, which is the donut-shaped. It has wide waist, large bone structure, and generally referred as round. There is the mesomorph, usually known as medium bones, solid torso, low body fat, and wide shoulders. And there is the octomorph, and a person who's tall and thin, has long and thin bones, long and thin muscles, low body fat, and generally referred as skinny. To calculate Heath-Carter rating system, you need height, weight, skin fold thickness, body diameter, body circumference. You put it into the diagram shown and you can calculate what body type your client is. Using those results, you can put this on a chart like this. It will help you find what sport is the best for your client or what sport your client is best suited to. Here I'll assess the suitability of anthropometric assessment and somatotype testing protocols that are used in lab-based testing. When the tests are done at school or colleges, there should be separate rooms for girls and boys, so that girls are comfortable and so are boys. This would reduce bullying and any unnecessary comments. As the people tested will be underage or young adults, there needs to be more than just two people, and ideally if there was another adult, so that if something happens, there is a witness. Researchers should ask whether the participants are comfortable at all times. When the tests are carried out in the gym, it should be done in separate rooms and not in a public, due to data protection and making the participant more comfortable rather than in front of other people. When it's done at the competition level, it's more likely to be more exposed due to less space available. It might also be done with other athletes due to smaller space. At elite level, elite athletes are most of the time used to nudity around others and not having a problem with exposing their skin, as they do it fairly often for massages and in changing rooms with other athletes. They also work with the same specialists and therefore they get used to it. However, they should still be asked whether they're comfortable, as everyone is different and they might not be comfortable with that. When those tests are done for social study, people are less comfortable with nudity around others most of the time. That's why it should be done in separate rooms. It also should be done in separate rooms due to data protection. Here are some advantages and disadvantages of each of the tests that I've done. Some of the advantages of Durham and Wormsley is that it's quick and easy to use. Not much equipment is needed, as you only need calipers. Only not one equation needs to be done to get the result you want. It's simple to carry out. It takes age into consideration. It's fairly reliable. However, it might not be accurate due to the fact that it's only 4 sites. It needs a second person to carry it out. It only takes few measurements and not the whole body. There are equations that can go wrong. The 4 sites are only at the top of the body. It depends on the grip, so there are multiple readings. It only gives body density. Different calipers may give different readings. And you need a special calculator, as logarithms are more confusing, so the calculation is not that easy. Next, onto normograms. They are simple and fast to use. They give you body fat straight away, and anyone can do it. However, you can't exactly compare males and females due to the different sites being measured. There is age restriction, only shows body fat percentages for people between 15 and 60 years old. It's relying on a line to tell you your results, therefore it might not be as reliable. It is more difficult. That's why someone needs to know how it should be done. It also shows a broad conclusion and not a specific one for a person. For BMI, there is easy calculation to use. It gives information that can be used for sport. Anyone can do it as long as they have data, and it only requires weight and height. However, the disadvantages: most dependent on human measurement, so might not be accurate. It doesn't give all of the information. It can go wrong if using wrong measurements. It looks at 2 dimensions rather than 3 dimensions, so not as accurate as PI. It's not looking at sports. And when looking at weight, it combines fat, muscle, and bone weight together, and muscles weigh more than fat, so sometimes professional bodybuilders are overweight, even though they're not. Finally, the Heath-Carter rating system. The advantages is that it tells you what sport you are most suited to. It takes into consideration lots of information about the body. It looks at looks at 3 different types of body and it gives a score in each one. Results can be easily interpreted. Equipment is cheap to get, and it takes account into bones and muscles and fat. However, there are disadvantages. Human error can occur when measuring. Some tests are not appropriate to the body type. For example, for mesomorph, you should focus on chest or waist measurement as it's more applicable. The tests are not exactly specific when suiting sport the person. It doesn't take into account the character of personality of the person. It's quite difficult to plot it manually when not using software. I have measured my client and I can use those results to interpret some information about him. My client is a college student. He's 17 years old and his main sport is gymnastics. While doing Durnin and Wormsley, his body fat looked at 10.92%. Looking at normative data, it is in the ideal section. As he's not an elite athlete, this is good as he's right in the middle of the ideal section. If he wants to improve, then he could work on decreasing his body fat. However, it is not vital, especially that he's still a teenager. While looking at normograms, the total of the free skin fold was 33 millimeters. This has shown me that his body fat is 9%. If this is true, then he is very fit. Athletes usually have single-digit body fat percentage, so it is very good. As a college student, he would not need to improve much. He is still in the ideal section in the normative data. It is important to have lower body fat percentage as there is loads of jumping and lifting up your own weight in gymnastics. So if there is less body fat percentage, you would weigh less and therefore last for longer during gymnastics performance. His BMI showed me 23.73. He's in the healthy section once again, which is good. He's closer to overweight than underweight, so this is something he might want to work on. However, as he's a gymnast, it is likely that his muscles are responsible for most of his weight and not fat. But he's a college student, so he could lose more weight and gain more muscle. Finally, there is the Heath-Carter rating system. His results showed that endomorph he's 2.2, mesomorph he's 4.6, and exomorph he's 1.8. This shows that he's mostly mesomorph followed by endomorph. According to this, he's not specifically suited to a sport, but he could change his diet and exercise plan easily to become wrestler or by gaining mass, or he could become a tennis player by losing mass. This is good for him because he can choose which sport he wants to play and easily change to fit the characteristics required. To become perfect for gymnastics, his sport, he would need to be more mesomorph. This can happen by training more and gaining body mass. He would also need to become more ectomorph. As he is still in his teens, he is most likely to still grow, and if he trains and loses weight, he'll become more endomorph and become perfect for gymnastics. Thank you for this presentation.